This is day 2 in the gas laws unit, and during this lecture we'll be talking about Boyle's law and Charles' law. The goals for this little section is that you are able to explain the effect of gas properties using both Boyle's and Charles's law, and that you can calculate an unknown pressure, temperature, or volume by solving algebraically. We're going to start with Boyle's law, and Boyle's law looks at the relationship between pressure of a gas and volume of the gas. So Boyle was the first person to really look at these two relationships. This is what he looked like. And in 1662, he proposed a law to describe the relationship between volume and pressure. So take a look at this graph and think for a sec. What is happening to pressure as volume is increasing? What Boyle's described was that for a given mass of a gas at constant temperature, the volume of a gas varies inversely with pressure. So I'm just going to go back to that first figure. You can see that as volume is, let's go the other way, as volume is decreasing, so as we go from left to right on the graph, volume is decreasing and pressure is increasing. So they are inversely related. As one goes up, the other goes down. We can simplify the relationship using this formula here. P1V1 equals P2V2, where P1 and P2 are the pressure, and the pressure can be in any unit. That's ATMs, kilopascals, millimeters of mercury, but they have to be the same on either side. And V1 and V2 are the volume, again in any unit, typically liters or milliliters, but they have to be the same on both sides. So let's look at an example of one of these problems. A gas has a volume of 30 liters at 150 kilopascals. What is the volume of a gas at 0.252 ATMs? So the first step in solving these problems is to identify the different variables that you have. The first gas would be P1 and P2 and V1, and then after it changes, that would be P2 and V2. So we know initially the gas had a pressure of 150 kilopascals and a volume of 30 liters. We also know that the new pressure is going to be 0.252 ATMs, and what we need to find out is the volume. Before we can do this problem, and I'll click back through there, we need our pressures to both be in the same units. In order to convert kilopascals to ATMs, we need the following conversion. 1 ATM has 101.3 kilopascals. So using dimensional analysis will lead us to see that 150 kilopascals is equal to 1.5 ATMs. Now we have everything we need to plug into this equation. We have 1.5 ATMs at a volume of 30 liters will be equal to 0.252 ATMs at what volume? So we will simplify and solve for the V2, and we will get 180 liters. The second law that we're going to talk about is Charles' law. And Charles' law looks at the relationship between the temperature of a gas and a volume of a gas. All this under constant pressure. And in 1787, Charles proposed a law in order to describe his observations. So looking at the graph here, think about what is the relationship between volume and temperature. What Charles has said is that for a mass of a gas at constant pressure, the volume of the gas is directly proportional to its temperature in Kelvin. And that second part is important. The temperature has to be in Kelvin in order for that direct relationship to exist. So going back to the graph here, you can see as volume increases, temperature increases. So that means it's a direct relationship between volume and temperature. We can simplify that relationship using this equation here. V1 over T1 is going to equal V2 over T2. And in this case, V1 and V2 are the volume, and that can be in liters or milliliters, but it has to be the same. And T1 and T2 are the temperatures, and those always need to be in Kelvin. In order to convert a temperature from degrees Celsius to Kelvin, you add 273. So if you had something that was 30 degrees Celsius, in order to convert that to Kelvin, you would take 30 and add 273. The temperature would be 303 kelvins. So let's look at an example. A gas has a volume of 4 liters at 27 degrees Celsius. What will the volume be at 153 degrees Celsius? So for this one, we have a V1, T1, V2, and T2, and we're going to fill in what we know. For the first one, we have 4 liters and 27 degrees Celsius, but that needs to be in Kelvin, so I'm going to add 273 to that, which means the temperature is 300 Kelvin. We don't know the second volume, but we do know the second temperature is 153 degrees Celsius. So we'll add 273 to it to get 426 Kelvin. Now we have everything we need to plug into this equation. 4 liters over 300 Kelvin is going to equal V2, that's our X, we don't know that one, over 426 Kelvin. You can simplify by cross-multiplying, and you'll get the volume, V2, is 5.7 liters. Just a side note, the final answer here, 5.7, has 2 significant digits because that is the least number of significant digits given in our original problem. If you have any questions, please don't hesitate to shoot them my way. Otherwise, you're going to be working on worksheet number 2.